Next up, they're asking for not correct. Always read the question, circle and underline, because it's just a very bad habit if you don't circle and underline this kind of thing. So this is HCl, and this is entirely correct. So this is the same as HCl. Chlorine shares 1 electron to get to fully fill out the shell. Hydrogen share 1 electron to get to fully fill out the shell. This is chlorine and chlorine, so they share 1 electron each to get to fully fill out the shell. That's correct. OH2 is like that, or you call it H2O, which is water. But then oxygen is group 6, so you only share 1 electron, another electron, so you still have 4 more, which means C is incorrect. And CO2, which is the last one there, we know it's a double bond because oxygen will form 2 covalent bonds. They need to share 2 electrons, and carbon will share 4 electrons. That's why you need 2 oxygen here to share 2 and the other one to share 2. CO2 is a case study. Make sure you can count 4 electrons shared is equal to 2 covalent bonds, and these are something we work out in the correction classes previously. Question 6, again, they want just the outer shell electron arrangement. So this is just basically the valence electrons. They want covalent compound, so sharing of electrons. This is between element in group 3, element in group 7. So if you have group 3, you will have 3 valence electrons, and group 7 will have 7 valence electrons. So group 3 and group 7. So how would this look like? Let's see. So Y is in group 7 and X is in group 3. So let's have a look at these. If you count it, so Y must have 7, right? So Y must have 7. So you see, if I do this, 1, 2, 3, 4, 5. So Y has 5 crosses. That one is wrong. You look at Y has 7 dot, Y has 7 dot. Again, Y has 1, 2, 3, 4, 5. So Y has 5 crosses. So A again is wrong. So we're left between B and C, and we're gonna decide about this. X is in group 3. If X is in group 3, hopefully you can see if I have 1, 2, 3, 4, 5. So X has 5x, but it's group 3. So you think about the logicality, it's impossible there. Whereas here you have 1, 2, and 3 crosses for the x, and then it is the answer that we're expecting because they share electrons, and y will share 1 electrons only. So x will share 1 electrons to partner it up, and this is a single covalent bond. Another single covalent bond, and another single covalent bond. Yes, I'm aware that around X is 2, 4, and 6 only, but it's just the way it is. Out of the 4 options, this is the best answer, just by counting electrons, something that we did as an exercise, as part of the learning objective when we cover through these in classes. Question 8, covalent compound. So we are looking at properties. Properties is not the process, not the process of sharing electrons, so be careful to read questions. It is all stated in the notes as well as the syllabus. Candidates should be able to state the properties of covalent compound. We have law, melting point and boiling point. These are high. This is a negative value, is below 0 degrees Celsius. This must be low. That must be the answer, because conductivity is one thing that covalent compounds do not conduct. So, with just these two, we can get the answer straight away. Very, very straightforward, based on what you know, based on your checklist of revision. Question 9, which elements react with each other to form ionic? So ionic compound, we are looking for metal and non-metal. So that is the process. Of course, the properties will be different story. So this is a group 2 metal, and this is a group 7 non-metal. So obviously A is the answer there. So that is a group 2 metal, and this is a group 1 metal. So metal and metal don't give you ionic compound. Nitrogen and hydrogen, so there's group 5. We don't give a group to hydrogen, but hydrogen has just 1 valence electrons and is obviously a non-metal. So you're gonna give you NH3, which is a covalent compound, NH3 is ammonia. Is one of the few case study you've got to know as stated in the syllabus, because you need to know how to draw the structure of ammonia, such as this, the dot and cross, and it will have low melting point and boiling point because it's a covalent compound formed by sharing of electrons between nonmetal and nonmetal. Sulfur is a group 6, as well as oxygen is group 6. Nonmetal and nonmetal, you will get you will get a covalent compound, and that covalent compounds will be very important in your year 10 and year 11 stuff. Example, SO2, SO3. This is called sulfur dioxide. Just like carbon dioxide, it has got 2 oxygen and 1 sulfur. This, on the other hand, is called sulfur trioxide because it's got 3 oxygen. So obviously we already gotten the answer there. We could have moved on. Just want you to know the idea of what kind of other compound you can form, but definitely not ionic there because it's between nonmetal and nonmetal. Question 11, sodium chloride. Sodium chloride is one of your case study. The syllabus says that you must know the formula and you must know how the Na go from 281 go to Na plus, which is 28, and the Cl go from 287 and become Cl minus, which is 288. So obviously we have a transfer of electrons where this one lose electrons, this one gain electrons, and we transfer the electrons to there. So there's a transfer of electrons, and as a result of it you get this ionic compound because it's formed between metal and non-metal, and you get cations and anion giving you ionic bond, which exists in ionic compound. Ionic compound will not have low melting point, it will have high melting point and boiling point. These are properties of ionic compound as stated in the syllabus, as well as the notes, as well as the exercise, as well as we did it in the corrections leading up to the test. When you are liquid, your ions are free to move, and as well as in the aqueous solution, when you dissolve in water. Aqueous means you dissolve in water. This was part of what we had done in separation technique. Separation technique talk about the elements, compounds, and mixtures. This is a pure substance, whereas in the aqueous state is a mixture because you mix the substance with water. So obviously the ions are free to move, and therefore they can conduct. When they're in aqueous as well as liquid state, and you will have high melting and boiling point. So C is the best answer there. Number 12, 2 atoms in a diatomic molecule. Molecule means 2 or more atoms bonded together. Diatomic means di means 2. Diatomic means 2 atoms. Molecule means bonded together in a molecule. 2 atoms chemically bonded together. They are looking for which one is not correct. Both of the atoms could be from the same non-metallic elements. This is correct because example, H and H give you H2, O and O give you O2, N and N give you N2. I've drawn triple covalent bond there because, as you know, 2, 5 and 2, 5 requires sharing 3 electrons each, whereas in the oxygen, obviously 2, 6 and 2, 6, you require to share 2 electrons each, and so on and so forth. Of course, then group 7, such as chlorine, bromine, iodines, so Cl2, Br2I2, and even F2, they are all single covalent bonds because you know how to fulfill and how to share electrons. You really need to share 1 electrons to get to a fully filled outer shell. So they can be from the same non-metallic elements. So this is not what the question want. They want not correct because we could read in English. One of the atoms could be from a metallic element. This is definitely wrong because you are looking for covalent. You are not looking for ionic. Alright, you're not looking for ionic. Covalent means between non-metals and non-metals. Between non-metals and non-metals. So, option B there is definitely incorrect. Option C, this is the objective of forming covalent bonds. So this is definitely correct. The 2 atoms share a pair of electrons. There's covalent bonds. So that is definitely correct as well. Question 13, which row describe how ions are formed, and which type of elements combined? You want ionic, so very clearly you want ionic. Ionic is going to be between metal and non-metal, metal and non-metal, so B and D is definitely out, so there's no need to look at that. How ions form? We know that they don't share electrons, because when they share electrons there's covalent bond, and the question very specifically asks for ionic bond, so it's to do with gaining and losing electrons. As I said earlier, you need to know the very basic thing about your case study. We did this as work 1 and work 2 under bonding leading up to the test. Of course, you did your own work. Of course, you actually understood what you did. Of course, you did the corrections if you got any wrong. And of course, now it's the stage for the test. You have understood that it's to do with the transfer of electrons. The metal loses the electron, and the non-metal gain the electron, such that you get cations after the metal loses the electrons, and you get anions after the non-metal gains the electrons, and that's how you get ionic bond before an exam or a test. Next up, we have sodium atom. Sodium atom is 281. It's a group 1 metal. It's got 1 valence electrons. It's in third shell because it's the first, second, and third period of the periodic table. Then you will lose 1 electrons and you become 28. Now this becomes fully filled. Just now you have sodium atom. Now you have sodium ion with a +1 charge because you already lost 1 electrons. So gain electron is wrong, lose electron is correct, and you form positive ions is Na+. These ions formulas, you gotta know them because they're very important for the next part of the topic. Question 18, so which one form an ionic compound? If you look at this is group 7, this is group 5. You look at the outer shell, this is group 6, not group 7, I beg your pardon. This is group 2. So these are all non-metal, and this is a metal. So if we want ionic compound, we want between a metal and a non-metal. So we're looking for group 2, which is Z. So Z can partner with any of them and it will be correct. So there's the only one option there where Z is a metal. Any of their partner which is non-metal will form ionic compound with Z. Question 16, an atom of chlorine has 7 outer electrons. This is the same as 7 valence electron because it's group 7. Oxygen has 6 outer electrons because it's group 6. You get a form between oxygen and chlorine. So oxygen, chlorine, this 287, this 26, so group 6 there. You need to share because we have non-metal and non-metals. So non-metals and non-metals will share electrons and form covalent bonds. Whereas here, you need to share 1 electrons. So in your exercise, I show you how to do the cross multiply thing. So we move down the number, we don't move down the electrons or the atoms, so it's 1 and 2 there. What does this one mean? The one on the left tells you the number of oxygen atoms needed, so 1 time oxygen atom and 2 times chlorine atoms. So it's going to be OCl2, so 1 oxygen and 2 chlorine. This cannot be correct because you need 1 oxygen and 2 chlorine, 1 oxygen and 2 chlorine, 1 oxygen, 4 chlorine, so C is out, 1 oxygen, 2 chlorine. Next up, we gotta think about each chlorine only share 1 electrons, so you only form single covalent bond from the chlorine. You only form a single covalent bond from the chlorine. This is wrong. Each chlorine only shares 1 electrons, so you need 1 electrons from oxygen. You only form 1 covalent bond, so not like that. If you count 1, 2, 3, 4, 5, 6, there are only 6 crosses, so D is out, and therefore A is the best answer there. Question 21, so conducts electricity when molten, but compound Q does not. So this must be covalent, and this must be ionic. Compound R is a gas at room temperature. Room temperature means 25 degrees Celsius. You learn this under states of matter, solid, liquid, and gas topic 1, as well as your lower secondary science before you go up to upper secondary. Gas, it already boils. It already boils at 25 degrees Celsius, so it's got low boiling point. This is a property of covalent compound. Compound as melts at that is high. Hasn't melted yet, it's still a solid. Still solid. At 25 degrees Celsius or room temperature, there's a very high melting point, so there's ionic. We are looking for covalent, so we have R and we have Q. So Q and R will be the correct answer there. 36, so P and Q combine to form the gas. Gas meaning covalent because it will mean low boiling point. Gas means you already boil because liquid to gas is boiling. So low boiling point, covalent compound. Covalent is between non-metal and non-metal. So we can cross out definitely option A because this is a metal. It's a group 2 metal. Because group 1, 2, and 3 metals, all right? So A definitely do not give you covalent compound. Next up, what do we have? We have PQ2. So P is to Q, you need 1P and 2Q. If you think about carbon and hydrogen, so you actually need to know the formula already. It's called CH4. It's called methane. This is in your syllabus as well as in your notes if you have a look at it, and also they're in your exercise as well as your example in work 4. So it's not like you don't know it at all. Look at the configuration and think about how many electrons this need to share. It needs to share 4 electrons, and this one needs to share 1 electrons, and then we cross multiply this number and this number, so altogether we will have 1 carbon, so 1 carbon, and we'll get 4 times hydrogen, so we get CH4. So it cannot be PQ2 cannot be carbon and hydrogen because it will be CH4. On the other hand, carbon oxygen will give you CO2, hydrogen and oxygen will give you H2O, but be careful, they want 1P and 2Q. 1 times carbon, 2 times oxygen. Here, your P is hydrogen, so 2 times hydrogen, 2 times P. 1 times oxygen, 1 times Q. So it cannot be D because you only want 1 of P and 2 of Q. This is 2 of hydrogen, 2 of P. So comes down to whether you know your formula as stated in the syllabus. Candidates should be able to state the formula of the common things as stated in the syllabus. 33, so covalent bond compounds. This is to do with properties again and again and again. Most of you couldn't get these for your structured or theory paper test where you talk about the processes about transfer and sharing electrons to compare covalent versus ionic, but the questions specify on properties. So these are the 2 properties stated in the syllabus. Candidates should be able to state that covalent compounds have very low melting and boiling point because you're just breaking the weak intermolecular forces. Break weak intermolecular forces. Inter means between, so we have forces of attraction between the molecules, and of course covalent compounds do not conduct, so do not conduct whether it's solid, liquid or aqueous. Covalent compound do not conduct at all because no free electrons. Whether you're in solid or liquid or gas, you don't have free electrons at all. So we are left with option D there. Question 34, covalent compounds and ionic compounds have different properties. These are what had come up for your structured paper, for your theory paper. Like I said, people didn't do very well because people were not covering the right stuff. They were not talking about the right stuff. There's no need to even read what you write if you don't talk about the right stuff at all. So this is not correct based on what the question is asking. They are not going to be more soluble in water. That is wrong. They are more volatile. Volatile is that English word I talked about just now. Volatile means boil easily. If you boil easily, it means low boiling point. A volatile person gets angry very easily. A volatile substance boil off easily. Low boiling point. Ionic compound, high boiling point. This is a correct statement. Covalent compound, they refer to covalent compounds. They do not conduct electricity. So this is correct, whereas ionic compound conduct electricity in a liquid state because you have free ions. They refer to covalent compounds, lower melting point, that is also correct. So I was correct that, option A was definitely incorrect based on what the question wants. Before, low electrical conductivity does not conduct, so therefore it is not, hang on. What can we say here? High volatility. This is play around with the English word. Volatile means boil easily. So a volatile person is a person who gets angry easily, is a person who boils off easily. So high volatility means easy to boil. Easy to boil means low boiling point. Okay, low boiling point means covalent. Alright, so end of story there. 25, so you want not correct. Be very careful to always read questions. They're very kind to ball it for you, but sometimes your eye and your brain play tricks on you. If you don't read the question, if you are not careful, you lose everything. Now, covalent bond forms when a metal atom donates an electron to a non-metal atom. This is ionic, so this is definitely not correct because it's not correct. It should be ionic bond. The metal will lose the electrons. Metal loses electron, form cations. The non-metal gains electrons and form anions. A covalent bond is a pair of shared electrons, so we know about that between nonmetals and nonmetals. Oxygen and hydrogen, so they give you H2O, which of course you know how to draw the dot and cross, which is your case study as part of your exercise, your notes, your syllabus, as well as coming out in various test questions as well. When atoms form covalent bonds that get same electronic configuration as a noble gas, this is the objective. Why? Why do group 5 gain 3 electrons, group 6 sharing electron, I guess. Why is it that we get NH3? Because the 2,5 configuration of nitrogen want to share 3 electrons. Why OH2 you only share with 2 hydrogen? Why HF or FH only share 1 electrons with the hydrogen? Because all of them will have the same configuration as a noble gas, because they want to go to a fully filled outer shell. Fully filled outer shell is always the objective. Question 37, so you want an ionic compound. Ionic compound is between metal and non-metal. So let's have a look at the outer shell, which is to do with valence. So here you have 1 outer shell electrons, here you have 2 outer shell electrons, so this is group 1. This is a group 1 metal, this is a group 2 metal. And 3, you got 2, 4, and 5, this is a group 5 non-metal. And last but not least, you have 2, 4, 6, 7, this is a group 7, and it's also a non-metal. So first of all, 1 and 3 is between metal and non-metal, 1 and 4 is between metal and non-metal, 2 and 3 is between metal and non-metal, 2 and 4 is between metal and non-metal. Not helpful at all. Alright, so let's see. You want x, y, and 2, so we need 1x and 2 times y. So we need 1 times x and 2 times y. So, okay. So we need something that either lose 1 electrons or gain 1 electron. And then we need something that will lose 2 electrons or gain 2 electrons. And we cannot have 2 and 2 together like this. So we have to think about the partner. So the partner that you can do is either lose 1 electrons and gain 2 electrons like this, or your other partner could be that way around. Doesn't matter which way around, but they got to match like that. So we gotta have 1 and 7, so we gotta have 1 and 7, where we cannot have 2 and 6, because 2 and 5. Anything to do with 5 would be wrong, because anything to do with 5, then it needs to gain 3 electrons. So you can't get the xy2 at all, so 3 is definitely wrong, 3 is definitely wrong, 3 is definitely wrong. So you're left with your 1 and 4. This is 1 and 7. If you have 1 and 7, I beg your pardon, the 2 electrons thing cannot be 7. It has to be 6 because 7 plus, 7 plus 2 will give you 9, 7 minus 2 will give you 5, whereas 6 plus 2 will give you 8. So it's got to be 1 and 6. So we cannot be looking at 7 at all. So 1 and 4 must be wrong because this is group 7. Must be 2 and 4. So let's have a look. So group 2 will be M2 plus, and then the group 7 will be the X minus, because it's got it get 1 electron like this, right? So you must have 2 of these, because, well, plus 2 minus 1 minus 1, the overall formula will give you mx2, where, if you have x and if you have y, perhaps I could make it into a better thing, like I don't know, b, so that it's not confusing between x and y. So mb2, which is xy2. The idea is compound is not charged. Compound has no charge, because the charges cancel out, plus cancel minus. That is your primary school mathematics, where you add up the positive and the negative together. Question 38. So which element forms an ion with a charge of 2 minus? So we want to form anion. Anion come from non-metals. Non-metal gain electrons. So the non-metals belong to group 4, 5, 6, 7. Not group 8, because group 8 is fully filled already. But you want to gain 2 electrons. So very specific, yeah. 2 electrons. So cannot be 4, cannot be 5, cannot be 7. Must be group 6. So we're looking at 6 valence electrons equal to group 6. They gain 2 electrons, and they will form an ion with a 2 minus charge, because it becomes 288. So in this next question, so we have this table which shows the arrangement of electrons, and these are in atoms. So we know that in atoms, number of protons equal to number of electrons, and these letters are not the chemical symbol of the elements, and they say use the letters. So we do not have to work out the element, we need to use the letters and to think about the information given. This is saying that there is first shell, and this second shell, and there's no third shell because it only fill up to second shell. So the first shell is completely filled with 2 electrons. The second shell, which is the outermost shell in this case, it's got 1 electron. So that means it's group 1, and group 1 is a metal, group 1 metal. And this one is a period 3, because it's got first shell, second shell, and third shell. And in the third shell, in the outermost shell, there's 5 valence electrons, so it's group 5. And this one is a non-metal. So moving on, what do we have? We have period 2, because there are 2 shells that are being filled, and this is group 6, and this is non-metal. And so on and so forth. This one is period 3 and group 7, and this is also a non-metal. Last but not least, this is period 3 and group 2, which is also a metal. So the group number basically tells you the number of valence electron or the number of outermost shell electrons. The period number, you can get the information by looking at how many shells are being filled. So here 2 shells are being filled, first and second. Here there's first, second, and third. So this is in period 3, and so on and so forth. So out of these, you can use the letter once, more than once, or not at all. So the element with the proton number 15, so we are looking at 15 electron also, because of what we have read earlier in the question. Of course, we read the question because that's the first thing that any sensible people would do. They read the question before they jump into the question. All right. So the element with the proton number 15 is going to be where the number of electrons add up to 15. So there are a total of 3 electrons here, 2 plus 1. So there's a total of 2 plus 8, which is 10, plus 5, which is 15. So we're looking at B as the only element with the proton number 15. That's the identity. The element with the nucleon number 35 and 18 neutrons. So if you think about this is like X, and then it's got 35, and we don't know the number at the bottom. That's what we don't know. We don't know the number at the bottom. So we know 35 minus whatever we don't know give us 18, because this is nucleon number and this is the proton number. Nucleon number minus the proton number, nucleon or the mass number minus the proton or atomic number, and that will give you the number of neutrons. They will give you the number of neutrons, and since we know that, then we got to work out what is our missing piece, and moving the minus missing piece to the other side, you get the unknown, and you get 35 minus 18, so unknown equal to 17. You work this out on your calculator. 17 protons. 17 protons would mean 17 electrons, because we are talking about atoms. So 2 plus 8 is 10, plus 7 is 17. So we are looking at D as our only possible answer. The next one is asking us on non-metallic elements. They're also asking us on the same period. So same period means same number of shells being filled in. We're looking at non-metal and non-metal because they say non-metallic, which are found on the right side of the periodic table from group 4, 5, 6, 7, and 8. This is group 4 non-metal. This is group 7 non-metals. They are in the same period because period 3 and period 3, first, second, and third, first, second, and third shell. So we're looking at B and D. All right, this is a metal. This is a metal. This is a non-metal, but this is in period 2 because they only fill 2 shells, so C cannot be the answer compared to these two which are in the same period. The next one, an element that form an ionic compound with fluorine. Fluorine is a group 7 non-metal. So you're looking for a partner. Ionic, your partner will be metal and non-metal. So since we have non-metal, we're looking for metal. Could be this group 1 metal. It could also be this group 2 metal. So A or E could be the answer here. They don't say the element. Here they say the. Here they say N, because there's more than one answer that's possible. So it could be the group 1 metal, which is A, or the group 2 metal, which is E. So either you put down A or you put down E, that will be correct as well. The element, meaning there's only one answer, gains 2 electrons. The fact that you gain 2 electrons means you're a non-metal. And specifically, why do you gain 2 electrons? Because you are stable and you want your ion to be stable because it will have a fully filled outer shell. And therefore, we're looking at group 6 because 6 plus 2 will give you 8 electrons, fully filled outer shell. Fully filled valence shell would be nice and happy. So we're looking at group 6, and the only group 6 element in this case would be element C. Okay, so on to the next part of the question. We got to complete the sentences about nonmetals. So nonmetals are found on the right hand side. So a lot of students have actually filled this in incorrectly, partly because 1, they just fill in the blank randomly, and 2, they don't know anything about a generalization of metals and nonmetals. These questions are meant to guide the students by giving information on the left as well as on the right. You got to think about properties. So these are properties as stated in syllabus as well as the notes. If we think about the nonmetals, we can think about nonmetals are mostly gases, i.e. we can think about H2 hydrogen gas, O2, N2, Cl2, etc., etc. These are part of the bonding topic. As you know, these are single covalent bond, double covalent bond, triple covalent bond, because you only want to share 1 electrons to complete the outer shell. Group 6, it wants to share 2 electrons to complete the outer shell. Group 5, it wants to share 3 electrons to complete the outer shell. Group 7, it wants to share 1 electrons to go to 8 electrons in the outer shell. Sharing of electrons, covalent bond, therefore, the properties will be low melting point. They also have a low density. They are mostly gases. They are not found on the ground level. And the other thing is they form negative ions. The other name of negative ion is called anions. So what happened to electrons? the nonmetals, the atoms will gain electrons or accept or receive electrons. And then the electronic structure of the negative ion, the anion, is stable, such as what we said just now. You want to form a stable ion because you want to get to a fully filled valence shell. Valence is the other word equivalent to outermost electron shell. So valence electron shell will be completely filled. Or you can say full, or you can say fully filled. They all mean the same thing. If your valence electron shell is fully filled, that means you are forming a stable ion. In this case, the negative ion, because you gain however many electrons in order to form a stable ion. On to the last part, nonmetals combined with metals, and this will give you ionic compound. If you want to get covalent, you want nonmetals with nonmetals, they will give you covalent compound. Alright, so moving on to the next part of the questions, we have electronic structure of an atom. This is atom, and the other one is atom. This is group 7, and it's in period 3. So as we mentioned just now, this is first shell, second shell, and third shell. So we're talking about period 3, and we're talking about group 7 because the outermost shell has 7 valence electrons. Speaking of which, this is the very answer to this part of the question. A lot of students, they put down because chlorine is a non-metal, and that's actually wrong, because they specifically ask you group number. In the syllabus, in the notes, they say students should be able to state group number tells you the number of valence electron. Group number tells you the number of valence electron. If you are group 7, that is because all the elements in group 7 has 7 outer shell electrons. So chlorine has 7 outermost shell electrons. Or we said chlorine has 7 valence or outermost shell electrons. Just choose either one and you'll be okay with whichever word you decide to use. However, you cannot put down just because it's non-metal. Not chlorine is a non-metal. Because if you say that is true, then every single non-metal I can also put in group 7 and that will be true. But that is not true for every single non-metal. There are some other non-metals that are put in group 6. There are some other non-metals that are put in group 5 because it depends on the number of outermost or valence shell electrons. So group 7 because there are 7 valence electrons. End of the story. Alright, so moving back to part A, they want formula. So I don't know why a lot of students, they put down configuration when they should be reading the question. Formula is not electronic structure, it's not electronic arrangement. Now they want ion and they want ion. So we know what happened with this sodium 2 at 1 and this chlorine and 2 at 7 is that the chlorine will receive the electrons from the sodium. So this one loses electrons. This one will gain the electrons, and you get Cl minus 1, and then you get Na plus 1. The whole idea of this losing 1 valence electrons and this coincidentally gaining 1 electron is because when this lose the outer shell electrons, the Na plus and the resulting Cl minus will become 288. Now they would have fully filled valence shell. Valence or outermost, you can choose either one, but should stick with just one that you are happy with. So now they have, not electrons, but shell. We are talking about fully filled outer shell. That's the objective of forming the particular ion with a particular charge, is because you want to form ions that are stable because they have fully filled valence or outermost shell. So the formula of the resulting sodium ion is just Na plus and the chloride ion is just Cl minus. Based on what you know about the very, very basic fundamental concept of electronic structure, they are given for free in the periodic table. You gotta know about what happened. You gotta know the resulting charges that this loses electrons to give you cation. Non-metals gain electrons to give you anions. On to the next part of the question. So they told you that it's ionic compound because you have a metal and a non-metal combined together. Now you got to give properties to show that it's ionic compound. A lot of students, they get confused between this word properties and the process. The process involving metal and non-metal, so there's the process involving the transfer of electrons from the metal to the non-metal. That is the process. You want properties as stated very, very clearly in the syllabus, and also I mentioned very, very clearly in the classes as well as lecture tutorials that you shouldn't revise without going through the syllabus and making sure that you understand and can master each and everything stated in the syllabus. The properties does not mention the process. There are two properties. The first one is to do with high melting and boiling point. The second one is to do with electrical conductivity. So ionic compound, or in this case sodium chloride, NaCl, the formula of which is stated in the syllabus as something you've got to know, because you have one Na plus as a result of one Cl minus. So ionic compound NaCl does not conduct in the solid state. So solid ionic compounds do not conduct, but it can conduct electricity. We are talking about electricity in the liquid, meaning molten, or aqueous, meaning dissolved in water. So all of these was already covered in the notes. You're not asked for the reason here, but the reason is because you do not have free ions in the solid state. The ions are in a fixed position, and the ions are free to move once they become liquid or dissolve in water. And the reason for the high melting and boiling point is because you have strong ionic bond. You need a lot of energy to break strong ionic bond, and these are all part of your summary notes, which you should have done yourself. We already gone through this in the class as well. They're also present in your lecture notes as well. This is carbon dioxide. So the structure of a molecule of carbon dioxide, CO2, as you know, carbon and oxygen, 2,4 and 2,6. You need to share how many? We're talking about sharing electrons because we have non-metal and non-metal, group 4 and group 6, non-metal and non-metal. You need 4 electrons. You need not 6 electrons. You need 2 more electrons in order to complete the outer shell. Complete the outer or the valence shell. That is the objective when you form covalent bonds. And then we do the cross multiply where the number 2 goes to the other side, and then the number 4 goes to the other side. This is number of electrons, this is number, and you need to simplify into the simplest ratio. And all this was done as part of your lesson notes. They're in your textbooks. They're also in the corrections that we did as a class, where everyone had the chance to ask questions if they were unclear on what is going on. So this 1-time carbon and this 2-time oxygen. So CO2 is going to be the formula of carbon dioxide when carbon combine with oxygen to get to a fully filled outer shell. This is one covalent bond. The bottom one is another covalent bond. So one covalent bond is 2 electrons because 2 electrons are being shared. So altogether, if you have 2 covalent bonds, you call it double covalent bond. You have 4 electrons being shared. If I say the carbon is cross, the oxygen is dot, then it looks like this. This is one covalent bond, 2 electrons. This is another covalent bond, 2 electrons. Being able to translate from these to these is very important. And of course, oxygen started from 6 valence electrons, being in group 6. These are outer shell, meaning to say these are valence. We don't care about the inner shell anymore. We care about you started with 6, you only use 2, so you still have 4 more. If you forget that you have 4 more, then you don't get the full mark. On the other side, you have the same double covalent bond. So what I have the 2 crosses from carbon sharing the 2 electrons, and the oxygen will share 2 electrons. And now the oxygen also has 4 more electrons, which are not used for bonding. So if you count now, the oxygen started with 6 dots because 6 valence electrons. It now share with 2 from carbon. Now this oxygen has 8 electrons in the outer shell. This oxygen started with 6 dots and it shared 2 crosses from the carbon, so now it has 8 electrons in the outer shell. This carbon started with 4 crosses and now it shares 4 of the outer shell electrons with 4 more, 2 from each oxygen. So now 1, 2, 3, 4, 5, 6, 7, 8. This carbon has fully filled outer shell. You got to check in order to get your full marks just like that. The next bit of the question was very badly done by a lot of students because you did not focus on properties. Properties is not the process, not like between metal and non-metal, blah blah blah, not like sharing or transfer of electrons, but rather properties are stated in the syllabus in your notes as part of electrical conductivity as well as melting and boiling point. So covalent versus ionic. Covalent compound has low melting and boiling point. Covalent compound has low melting and boiling points. These are stated very clearly. They are not asking you to explain, they're asking you to state, but they say differ. So you got to talk about ionic compound as well. Ionic compound is in contrast, so it has high melting and boiling point. You got to know how to explain it as well because they stated in the syllabus. Candidates should be able to state and explain, describe and explain. All right, so that is to do with melting point and boiling point. The next thing is to do with electrical conductivity. This is also stated in the syllabus as well as the notes. Those who didn't do the complete checklist, that means you did not completely revise no matter how long you spent on revision. If you do not complete the checklist from the syllabus, you are not doing an effective revision at all. So covalent compound does not conduct electricity at all. Does not conduct electricity at all, whether you are solid, liquid or gas or aqueous. But ionic compound, so we know ionic compound can conduct electricity when aqueous conducts electricity only when liquid or aqueous. Aqueous mean dissolve in water. Liquid mean when you melt it to become liquid. All right. So you got to talk about the two different properties. These are properties, and these are not the process itself. When you start talking about the process, straight away you get marked down to 0.